Hey guys, this is Mr. C, and in this video we're going to be discussing how to convert between radicals and rational exponents. And so the first thing that I'm going to show you is a little graphic organizer that shows you the procedure and how to convert from a rational exponent to a radical expression. And so the first thing, it goes from a rational exponent, m over n, m is the numerator, n is the denominator, and we see that we want to turn this into a radical, and when you do, the m is going to be the exponent on the base, and the n is going to be the index of the radical. And this is just a way to write this. So there's no real procedure that goes into this other than just knowing where to put the m, the numerator, and where to put the denominator. And so you're going to see problems, especially in Algebra 2, where this expression is going to be much easier to work with than this one, believe it or not. As a matter of fact, you could even take this and go one step further, and you can write it as the nth root of a, and then with an m on the outside. And there are times when this is actually even easier to simplify expressions in classes that are above Algebra 1, Algebra 2, and pre-calculus, and so on. So that's basically what we're going to do. And so let's take that, and let's look at our first example. And we have the fourth root of x cubed. So how do we turn this into an expression with a rational exponent? Well, as we saw, the power, or the exponent with the base here, is going to be the numerator, and this is going to be the denominator of the fraction. So 3 over 4. And so the way I kind of do it is I kind of look at these two numbers here and kind of turn them around, and that's how I make my fraction right there, 3 over 4. So you just take that, twist it around, and then that's how you get your 3 over 4. So what's the most common mistake? Well, they'll take these two numbers and switch them. They'll take 3/4 and make 4/3 out of it. And that's just a mistake in the procedure. And so we don't want to make that mistake. So we're going to be real careful with how we do this. All right, so these are going to go kind of quick. Okay, here's our next one. And if you get one like this, this is a square root of x to the 7th. So it helps sometimes to put a little 2 right there, because for square roots, generally we don't write that index right there. And so how do we write that as a rational exponent? Well, we're going to do our x, take this, twist it around, 7 over 2, 7 over 2, and then that's it. Okay, in this one, they're going to get a little more complicated because you're going to get more stuff underneath the radical, which is fine. How do we do this one? When we have extra stuff under there, generally this is what we want to do. We could write it as 3x squared to the 1/5. But the better thing to probably do is to think about this like this is the 5th root of 3 times the 5th root of x squared. And so what you might want to do is you might want to actually write this as 3 to the 1/5 times x to the 2/5. So that's one way to do it. The only other way you could write this is you could take this whole thing, if you wanted to, and you could put 3x squared to the 1/5 like this. But what's going to happen is when you distribute this exponent here, which you're going to have to do because we consider this to be unsimplified, when you distribute that, then you're going to wind up basically with 3 to the 1/5 and then x to the 2/5, because 2 times 1/5 is 2/5. You're going to get the same answer anyway, both ways. So this would be more than likely the back of the book answer there. All right. And each one of these is different. So I try to throw as many different kinds of problems in here as I can. Okay, let's do this one the same way. 8 to the 1/3 times x to the 4/3. Now you might think that this is done, but if you realize 8 is a perfect cube, 8 is 2 cubed. And so if you write that 8 as 2 cubed to the 1/3, and you multiply these out, you actually get 3 times 1/3 is actually 1. And so that's actually equal to 2. So this would not probably be the back of the book answer. The back of the book answer would be probably something like this: 2x to the 4/3. And that's really what we want to do. We want to simplify things as much as possible. And it takes practice and it takes skill. And so this is the answer that we'd want to get towards, at the end of our learning here to simplify it completely. Okay, let's do this one. Okay, so we got 1/4, so 5 to the 1/4 times x to the 6/4. Now, nothing irritates a teacher or professor more than a fraction that's not simplified, I promise you. So when you get this 6/4 right there, even though on the EOC, generally that's okay if you type that in, they'll accept it. Your college professor is going to make a face, not a fun face either, when you leave fractions like this. So we probably want to write our answer like this: 5 to the 1/4 times x to the, instead of 6/4, we'll put 3/2 in there. And then that's fine. Okay, now we've got a couple different variables in here, so let's see how to handle those. Again, we have a square root, so I'm going to put a little 2 there to remind us that that's the index. The power of x is 1. So we have x to the 1/2 times y to the, now let's think about it, 6/2. Again, we don't want to leave 6/2 sitting there because that's not simplified. And then what a lot of professors think is that, hey, you've been taught this since what, 4th, 5th grade? I mean, you should be able to do this. And so they're going to generally think that a student's lazy when they leave it like this. So we don't want to be perceived as lazy. So x to the 1/2, y to the 6 divided by 2 is 3. That would be the back of the book answer. All right, let's try this one. And so we see that we're going to have some increasing difficulty as we go. No big deal. Okay, this one. This is 81 to the 1st power, right? But remember, 81 is 3 to the 4th power. And so I'm going to go ahead and I'm going to write that 3 to the 4th power there, right? To the 1/4 times x to the 3/4 times y to the 2/4 would be the same thing as 1/2. All right, so let's see if we can do this one more time. This right here can be simplified. 4 times 1/4 is basically 1. And so you're going to get 3 x to the 3/4 y to the 1/2. So why am I doing it like this? Because students will arrive at an answer that's different. They might write something like this: 81 to the 1/4 x to the 3/4 y to the 2/4. And although they're not wrong, it's not simplified all the way. And so what happens is they get this answer, they look in the back of the book, they see this answer, and they're like, hey, I got it wrong because the only part I got correct was this. When in fact, they should have taken this, simplified it, and taken this and simplified it, and then you get the answer in the back of the book. All right, let's try this one. So we're putting one more variable in there, it looks like, which is fine because on the ACT, you see these quite a bit. Little x to the 1st power. So let's do x to the 1/3, y to the 2/3, z to the 4/3 is 4/3. People ask me why I put a little line in my z's, because I don't want it to look like a 2. And sometimes I have sloppy handwriting, and so that just kind of makes sure that I know that that's a z and it's not a 2. All right, so that would be an answer that's done. All my fractions are simplified, and so I'm good to go. Okay, so now we have one that has an 8 as our index. So we know how to handle that. 4 divided by 8, or 4/8, would be simplified all the way to 1/2. But let's do this. Let's just go ahead and write 4/8. Y to the 10/8. And z to the 3/8. So then we're going to take a look and see, are my fractions all simplified? Well, no, these two can be simplified one more time. So x to the 1/2, y to the 5/4, and z to the 3/8 is fine. That's already simplified. Okay, so always make sure your fractions are in least terms or completely simplified. All right. And let's try this one right here. The pages are sticking together. There we go. Okay, so 12, 6, and 3, and you got a 9 right there, so we know we're going to have to simplify some fractions here. So x to the 12 over 9, y to the 6 over 9, and z to the 3 over 9. Now, when things get more complicated, I don't want to do everything in one step, because if you do, then you're going to start losing people. So let's just do this in one more step. 12 over 9, both these are divisible by 3, so that would be 4 over 3. Y to the 6 over 9 would be 2 over 3. Just divide them both by 3. And z would be 1/3. And then there you go for that. That's it. That's all you have to do. I've seen that one on the ACT many times. All right, now we're going to start going backwards. We're going to convert these expressions into radical form. And so we're going to have a radical. This denominator is our index. And the 3 is going to be our exponent on whatever our base is. And that's it. That's all you have to do. Okay, this one. Okay, so again, our 3 is going to be our index. 2 to the second power. But notice that we have a numerical base right there, and so we can actually take 2 squared and write 4 out of that. So really what we should do is write the cube root of, instead of 2 squared, 4. That would be the back of the book answer on that one. Okay, so now we have a couple things going on here. Now is the time where we need to distribute, because we remember our properties of exponents. Like this, you could distribute it first if you wanted to, right? So you could say x to the 1/4, and you could say y to the 1/4. You could do that. But if you do that, I mean, how am I going to write that now as a radical, right? So I have 2 of them right now. Probably the better thing to do would be to do this. Take your denominator, make that your index. Take this right here, xy, and take that numerator and make that your exponent. And then once you're inside the radical, then distribute it. Well, it's just a 1, which means it's just xy. So the 4th root of xy for this one would be the end. If that was a different number up there, like a 5 or a 7, then you would have to deal with that under here by distributing it. But we don't have to do that for this one. All right. Okay, so this one, again, I'm gonna make this a little easy on me. I'm gonna go ahead and take my 5 right there as my index. X to the 4th, y cubed. Now all of that's going to be to the first power here, so I don't need to write parentheses 1. I can just leave it like this because I have a 1 in the numerator, and then that's my back of the book answer right there. That one's done. Okay, this one, we have a common denominator here. So what you can do is you can take it, these are both common denominators. You can take this and you can make that your index because they're both the same. And then what you can do is in the inside here of the radical, you can just take x to the 1st, y to the 4th. And that one is done, right? Just like that. No problem. And if you go backwards, that would be x to the 1/3 and y to the 4/3, and you get the same thing back that you started with. So what happens when the fractions do not have the same denominator? Well, what I'm going to have to do is make them the same denominator to use that same mechanism. So x to the 3/4, y to the, instead of 1/2, I'm going to put 2/4 there. Because 2/4 is the same thing as 1/2, but I do get a common denominator. So my index will be 4, and then x cubed y to the second power squared. And that one is done. Okay, so again, I do not have a common denominator. I definitely don't want to add these two together because the bases are different. So I'm going to take that 2 and write that with something as a 5 in the denominator. So x to the 3/5, y to the, so what would that be? What is 2? What fraction is 2 equivalent to that has a 5 in the denominator? Well, that would be 10 over 5. 10 divided by 5 is 2, right? And now I have the same denominator. So now, 5th root of x cubed y to the 10th. And that's it. Okay, this one now I'm adding on an extra variable just to show you that it's really not that complicated. And my pages is sticking together. Nope, not that one. Okay, so common denominators all the way. So I'm going to get a 2 here. So it's square root. And if it's square root and you write the 2 there, that's fine. Nobody's going to mark that wrong. It's no problem. X cubed. Y to the first power. I could write a 1 there, but I'm not going to. Z to the 5th. I just can't bring myself to put a 1 there because it's not necessary, and I'm in the habit of not putting it there if I don't need it. And that one's done. Okay, last 2. So let's take a look at this one. Okay, so here I have a 6, a 4, and a 3. So I'm going to have to fix up these 3 fractions so that I get a common denominator. So what's the least common multiple of 6, 4, and 3? And to me, that would be 12, right? So that would be, instead of 6, if I have a 12 here, 6 times 2 is 12. So 5 times 2 is 10. Y to the 4 times 3 is 12. 3 times 3 is 9. And z to the, okay, 4 times 3 is 12, 4 times 1 is 4. And now that I have the same denominator all the way through, now I can put my index up here, x to the 10th, y to the 9th, and z to the 4th. And that one is done. Seen that one on the ACT. And finally, our last one, 9, 2, and 6. All right, so what's the least common multiple of 9, 2, and 6? It's probably going to be, I'm thinking 18. 18, these 3 numbers all go into 18. That's probably going to be the smallest. So let's see, x to the, something with an 18 here. 9 times 2 is 18. 7 times 2 is 14. Y to the, 9 times 2 is 18, 9 times 3 is 27, and then z to the, 6 times 3 is 18, 1 times 3 is 3, and then once I get my 3 fractions fixed up, 18 will be my index all the way, x to the 14th, y to the 27th, and z to the 3rd power. And that is it. And that is how you convert from rational exponents to radical form for expressions. All right, guys, hope this helps. Remember to like and share, subscribe to my channel, and we will see you guys later. Bye.